Hello everyone. In this video we're going to be solving the integrals of powers of secant x. So we're going to start with secant x. Secant x is not very easy to integrate. If you think about it, you can write it as 1 over cosine, you can do a couple other things, but let's just go ahead and do this in a different way. So what I will do here is I will multiply the secant x by secant x plus tangent x, and then divide by that. Now you're going to realize why we do this in a minute. So the numerator is going to be secant squared x plus secant x times tangent x divided by secant x plus tangent x. You may have seen this method. This is very popular. All right. This is very common. You'll see them in the textbooks most of the time. And I'll show you a second method as well. So the reason why we use this substitution, or I should say, manipulation, is because if you look at the denominator and call that u, its derivative is going to be the derivative of secant x, which is secant x times tangent x, and the derivative of tangent is secant squared. So you basically get the derivative in the numerator, which means that if I do the u substitution, I basically get du over u here, which is integrated as ln absolute value of u plus c. And then since the u is secant x plus tangent x, from here, I basically get that the integral of secant x dx to be ln absolute value of secant x plus tangent x plus the constant. Okay? So this is the integral of secant. Awesome. Let's go ahead and proceed to higher powers. Now, you might be thinking the higher the worse, but that's not true for secant, because the integral of secant, by the way, I forgot to write the x here, secant squared x. Okay, how do you integrate secant squared x? Well, if you know that the derivative of tangent is secant squared, then you can integrate it. How? Well, this is equal to tangent x plus c. That's it. Okay, we're done. Cool. That was quick. Awesome. So now we're going to go ahead and take a look at the integral of secant cubed x. Okay, let's go ahead and take a look at that. Is it going to be this easy? Nope, it's not going to be that easy, but it's going to be easy overall. Okay, so what can I do? You know that with trigonometric functions, this is a very common trick. If we have an odd power, we separate one of the powers, and then we try to use some identities, or we use the u substitution, so on and so forth. Unfortunately, that doesn't work directly with secant. So, but we're still going to use the same approach, similar approach, I should say. But we're going to separate it like this time. It's a little different than the u substitution. It's actually the other way around. Okay. So, I'm going to separate the secant cube into secant times secant squared. And notice that I keep the secant squared x with dx. There is a reason for that, because I'm going to be using, guess what? Integration by parts. Ta-da! So it's the u dv method, right? Okay. So if I call this u and if I call this dv, well, where does the integration by parts come from? It comes from the derivative of the product. Okay? That's where it comes from. Very easy to prove. Okay, cool. So let's write down what we have. We have that u equals secant x, which means du would be the derivative of this, which is secant x tangent x. We just talked about it. Don't forget the dx. And then if dv is secant squared x dx. By the way, if you're doing integration by parts, you have to make sure one thing. One thing that you need to make sure is whatever you're picking as dv, and obviously if you choose u, dv is automatically chosen, right? Okay, it needs to be easy to integrate. Okay, so easily integrable function will be dv, and everything else would be u. U doesn't really matter. It could be, it doesn't, because it's not going to be integrated, right? Basically. Okay, anyways. Let's go ahead and proceed. If dv is secant squared, then v is going to be the integral. We're not going to use the constant here, but that's going to be tangent x. Awesome. And then how does the method proceed? As you know, the integral of u dv can be written as uv minus v du. Okay. Again, this comes from the product rule. Okay, cool. So we're going to go like this and then like that, but this is going to be a negative. Okay? That's what we're going to do. Let's see what we get from here. Secant x tangent x. Nice. Okay, that's cool, easy. Minus, okay, what do I have inside the integral? I have secant x multiply by tangent squared x dx. Okay, now what am I supposed to do at this point, right? You might be thinking, okay, now I get this, now what? Okay, well, here's the thing. Since tangent is squared, we can actually turn it into something that has secant in it. Why? Because as you know, secant squared is equal to 1 plus tangent squared, right? So tangent squared can be written as secant squared minus 1. Awesome. Let's go ahead and do it. But let's not forget where we come from, because that's going to be useful. So secant cubed x dx, the integral of that will be secant x tangent x minus, okay, minus the integral of what? Secant x times secant squared x minus 1 dx. Beautiful. Now I'm going to go ahead and distribute it, and I'm going to separate these integrals. But when I separate, I got to be careful, because negative times negative is going to be positive. Okay, awesome. So I have secant cubed x dx is equal to secant x tangent x minus, I'll be getting secant cubed x from here, notice that, plus the integral of secant x dx. Awesome. Now, we were trying to evaluate an integral, and then we got another integral. Well, I shouldn't say another, because we got the same integral. Beautiful. You can call that I, and a lot of times people are going to call that I and solve for I. We don't need to do that. We can just add this guy to both sides, right? And when we do, what are we going to get? We're going to be getting 2 times the same guy, right? So that's going to look like this. 2 times the integral of secant cubed x dx is equal to secant x tangent x plus the integral of secant x dx, which is something we already calculated, right? So we know the integral of secant x. We can go ahead and solve this. How? Let's see. So, and we're not going to put the c yet. Okay, we're going to do that at the end. So 2 times the integral of secant cubed can be written as, should I divide by 2 at this point? Nope, not really. Okay, I'll do that later. Secant x tangent x. What's the integral of secant? We just talked about it, remember? It was ln of absolute value of secant x plus tangent x, right? Okay, let's not put the c yet, because we'll do that at the end. What is the end? Well, we have a 2 here, but we're trying to solve for what? See, oh, we were trying to solve for this integral, and it just came up. Well, we're kind of solving it without solving it. Okay, it's kind of weird. But anyways, divide both sides by 2. To keep a long story short, you'll be getting 1/2 of secant x tangent x plus 1/2 of ln absolute value of secant x plus tangent x plus c. Wow, that is some integral, right? Well, wait until we get to the 5th power. Awesome. All right, so this is the integral of secant cubed x. Here we go. Obviously not as easy as secant squared. And also notice that we needed the integral of secant for this one. So that's some type of reduction formula, in other words. Also remember that we kind of calculated in a different way, right? So we didn't actually find the integral, but we found it. So it's kind of weird. Anyways, here comes the 4th power. Okay, what do you think? If you have a 4th power, it's going to be what? Something squared, right? I mean, you can't really separate a power. It's not going to help you. Secant cube doesn't really equal anything good. Okay, so what am I going to do then? I'll write this as secant squared x squared dx. Beautiful. Now, again, using our identity, I can write this as what? Tangent squared x plus 1. Of course, it needs to be squared and then the x. Awesome. Now we have a square. Let's go ahead and expand it, because what's going to happen? Something good is going to happen. Okay. You guessed already? Well, we're going to be getting powers of tangent. All right. That should look familiar. Did we talk about it? Yep. In another video, we talked about powers of tangent. Actually, that was the previous video, right? So 4 days ago. Awesome. Because we do this every 4 days. Plus 1, right? So I just, screen just goes crazy. dx. Okay. Now, what are we going to do now? We're going to separate them. So I get tangent to the fourth power of x dx plus 2 out tangent squared x dx plus 1 dx. Beautiful. Now, do we know the integral of each piece? Yes. Okay, we do. Now, if you remember, or just look it up or check the other video, the integral of tangent to the fourth power of x was tangent cubed x over 3 minus tangent x plus x. Awesome. What about the integral of tangent squared? So for tangent squared, we use that trick. Remember that? We said that, okay, I'm going to write this as 1 plus tangent squared x minus 1. And you know the integral of 1 plus tangent squared, which is secant squared, is tangent. So it's going to look like tangent x minus x. If you integrate this, you'll get tangent squared. Why? Because, if you differentiate it, derivative of tangent x is secant squared minus 1 is equal to tangent squared. So it checks. Cool. And this guy over here is going to be what? X. Okay, interesting. What do we get from here? But one thing we forgot to do is there's a 2 in front of this. So let's go ahead and put that down here, obviously, right? There's a 2 outside, so we should add that. Okay, now let's go ahead and simplify this a little bit more. Tangent cubed x over 3 minus tangent x plus 2x plus 2 tangent x minus x plus x. These two already canceled out, right? Okay. Now, so what do we get from here? Oh, this also should be multiplied by, I think we should do it in a nicer way. So let's go ahead and fix this problem here. So let me go ahead and back up a little bit here. Okay, here we go. So we said that this is going to be written as 2 times the integral. Let me write it as an integral first so we don't get confused. So you can just separate it like this, right? Like this, and then plus 1 dx. Cool. I could actually integrate that, but that's okay. Tangent cubed x over 3 minus tangent x. Now, I'll keep the 2 outside, so then integrate everything. Okay, 1 minus 1, actually, what's going to happen is that they're going to cancel out, right? Well, we don't want that because we want this one. So that's going to be secant. What am I talking about? Okay, this is going to be tangent x minus x when integrated, right? Okay, cool. And then I'll have plus x plus c. Beautiful. Let's go ahead and simplify this now. Tangent cubed x over 3 minus tangent x, okay, plus 2 times tangent x minus 2x, right? We're going to be getting a 2x there, plus x, okay, plus x. And I think, oh, okay, we forgot to write one thing here. In the integral of tangent to the fourth, we also have another x. Sorry about that. Let me add that x real quick. Okay, now this would work. So what's going to happen is that the x and x is going to cancel out with the 2x. Then I'm going to be ending up with this. So the integral of secant to the fourth power of x dx is going to equal tangent cubed x over 3 plus tangent x plus c. Okay, let's go ahead and quickly check this, okay? How do you differentiate this? Okay, just differentiate tangent cubed. You would write it as 3 tangent squared, and you would use the chain rule. The derivative of tangent is secant squared, right? Okay, cool. And then the 3 would cancel out. So basically you would get rid of those. Plus the derivative of tangent is secant squared x. Derivative of c is 0. Great. That's why we have a constant. So now I can take out a secant squared because it's a common factor, and I get tangent squared x plus 1, which is equal to secant squared, and secant squared times secant squared is secant to the fourth power. Yay, success. So we got it correctly. Here we go. Our solution checks. Let's go ahead and take a look at secant to the fifth power of x, and this is going to be real fun. Now, what am I going to do here? I'm going to use the breakdown method. So, but I'm going to break it down this way. And you are probably already familiar with this, right? For the third power of secant, we use this method, but this time we have the third and the second. Make sure to always have the second separated along with dx because we're going to use integration by parts. Okay, ready, set, go. So this is going to be our dv and this is going to be our u. Okay, so what do we write? U equals secant cubed x. So du is, okay, how do you integrate, differentiate, oh, confused. Okay, how do you differentiate secant cube? Okay, it's 3 secant squared x times the derivative of secant. Chain rule. What's the derivative of secant? Secant times tangent. Beautiful. And don't forget the dx. So du is going to be what? 3 secant cubed x tangent x dx. Beautiful. And dv is secant squared dx. So v is tangent x, right? That was easy. So now we're going to go what? uv minus v du. Here we go. There's a minus sign here. Okay. So then we get what? The integral of secant to the 5th power of x is equal to u times v, which is secant cubed x times tangent x, minus v times du. That's going to be a 3 outside, secant cubed x multiplied by tangent squared x dx. Awesome. Well, maybe not very awesome, right? Because we still have a hard integral here. But guess what? We are going to do something. What is that thing? Turn this into secant. Beautiful. We're dealing with powers of secant, so we should turn everything into secant. So now my integral is going to look like what? Secant to the 5th power of x dx is equal to secant cubed x tangent x minus 3 times the integral of what? Secant cubed x times secant squared x minus 1 dx. Beautiful. Now I'm going to go ahead and distribute. Okay. I'm going to go ahead and distribute those. And that should give me what? Secant cubed x tangent x. Now, inside the integral, I'll get secant to the 5th power minus secant cubed x dx. Beautiful. Then I'm going to go ahead and distribute the 3 and separate this into 2 integrals. Let's go ahead and see what happens. Secant cubed x tangent x minus 3 times secant to the 5th power x dx plus, notice the plus sign, 3 times the integral of secant cubed x dx. Okay, cool. Is this better? Yes, of course, because what happens here is now you have the same integral that we started with. Yay, we can do that again. So add that to both sides. You'll be getting 4 times the integral of what we're looking for, whatever that is, thingy. 4 times the thingy is equal to secant cubed x tangent x plus 3 times the integral of secant cubed. Now, what was the integral of secant cubed? Let's go ahead and refer to the result that we have found a while ago. It was this guy here. Wow, that's gigantic, right? Well, we can do that. Let's go ahead and copy that here. Hocus pocus, copy, paste. Okay, so we're going to replace the integral of secant cubed x dx with 1/2 of secant x tangent x plus 1/2 of ln of absolute value of secant x plus tangent x. And then the whole thing will be plus c, of course. Okay, let's kind of write it in a nicer way. And what's going to happen is when you distribute the 3, you'll basically be getting 3/2. But then you're going to multiply by 1/4. 3/2 times 1/4 is going to give you what? 3/8. So these two guys here are going to have 3/8 as a coefficient, and this is going to have 1/4. So let's go ahead and write our result in a nicer way. So the integral of secant to the 5th power is going to equal 1/4 of secant cubed x tangent x plus 3/8 secant x tangent x plus 3/8 ln absolute value of secant x plus tangent x plus c. Awesome. And this is going to be the integral of secant to the 5th power. All right, so I think we're going to stop here. We're not going to go to 6 power. Maybe in another video we can do higher powers. Don't forget to comment, like, and subscribe. I hope you enjoyed the video. I will see you in the next one, which is going to be a great geometry puzzle. See you tomorrow with a geometry video. Take care. Bye-bye.